After I graduated from MIT with a doctorate degree, I feel I don't like. Initially, I did not want to be in the teaching profession, and I decided to go to the industry to see what the industry was like. And so the first thing I did was to look up the Boston Globe, the section of employment, and found a company in Boston called Cram and Ferguson. It's a architecture and engineering consulting firm, and their project was to build the tallest building then in Boston called John Hancock Insurance Company. And so I thought, at the time I was a graduate from civil engineering, major in structure. So I applied and was accepted. I worked for the company for, the job I was assigned to do was supposedly design the structure of the building. And however, the job I was assigned mostly to select beams, girders, columns, and many of them just from reference books, and I found it was very tedious and not very interesting, not very inspiring. So I decided after less than a year, I decided this is not what I want to do. And so I went back to, then there's a MIT alumni placement office. I went there and I asked if there's any opportunities, actually not necessarily from MIT, but from whatever job opportunity they have listed. Anyway, the person in charge gave me a list. Finally, I found a position right in MIT, and it's a research lab. And at the time, right after the war, there were many government-sponsored research labs, including the laboratory which developed the radar, and there are other government-sponsored project, including the one I applied to called DACL, which stands for Dynamic Analysis and Control Lab. And there were others called servo labs. There was also computer research lab. Anyway, I applied for the, in Harvard, there was also a computer lab. And I applied for the DACL, Dynamic Analysis and Control Lab. And I found the work was much more interesting. I was assigned to do the fluid dynamics inside a control valve, and sort of a partly theoretical, partly practical research. And I spent over a year's time to finish the research. At the time, my supervisor, his name is John Blackburn, and he is a physicist, and he was very friendly with me. He said, you should publish a paper. And it never occurred to me I should write a paper, because I was new in the doing research, writing paper stuff. So he sort of guided me write a joint paper, and with my name first and his name second, and we eventually published 2 papers, both in the American Society of Mechanical Engineers, ASME, the transaction of that organization. It's a relatively prestigious place to publish things related to mechanical engineering. Anyway, after the paper was published, I got companies in the industry who do control valves to come to me to ask me to be consultants for their company. Of course, at the time, MIT, before that, after I published the paper, the head of the lab, who is a full professor of mechanical engineering department, he must appreciate my work and invited me to be on the faculty of mechanical engineering department with the title of assistant professor. I, of course, very glad to accept the title, and I was given one fluid mechanics class to teach. In addition to that, I was also doing other research work. But at that time, because the publication of the paper, I was invited to be the consultant of a couple companies. At the time, MIT was very give a lot of leeway to the faculty members. They allow the faculty members to spend 2 days a week doing their own work and consulting work or whatever other work. So at the time, one of my interests was to start from when I was younger to sort of a hand-on type. I like to use my hand to build things. So I started to sort of invent and improve a servo valve, electric actuated servo valve. And I showed the product to the company I was consulting for, they were the manufacturer of part of their product was to manufacturing control valves, and this is something different. So they were so happy to see something different, and he offered to buy out the patent rights of my invention. And I was so glad that not only my work was accepted, but also they offered to pay me a substantial amount of money, which at the time roughly about 7 times my annual salary of MIT, and I happily accepted that. By that time, my brother, Dr. Y.T. Lee, he was 4.5 years older than me, and he came to the USA early on, and returned back to China to work for the government as a engineer in a aircraft engine factory in Guizhou province.
So that was in the 1950s?
That was 1930 or 40 or so. Yeah, China is fighting the Japanese, and everything moved to the inland, and Jiang Jieshi, of course, encouraged the Chinese Air Force to build, to try to start a engine manufacturer by licensing from Curtiss Wright, I think, to build engine themselves. And my brother joined that group and worked for a few years. And then after the war ended in 1945, he came back to the United States. And he was originally graduated from the Aeronautical Engineering Department of MIT. So he rejoined the MIT faculty also as an assistant professor. So at that time, we were so glad that we were together, and also happened that we both have the same interest. We were interested in innovation and starting up companies, and since we both are professors, and his research work related to internal combustion engine, and at the time they like to be able to measure the pressure under inside the cylinder, which requires a high temperature transducer. And he designed a very ingenious water-cooled transducer so that it could measure the pressure under high temperature condition. And just so happened there is a company near in Boston, in Norwood, called Norwood Control. The company was interested in licensing his design and pay him a fairly good license fee too. So two of us got together. We said with the money I got from the control valves and he got from the designing the high temperature sensor, why don't we start a company? And at the time, MIT was quite, as I said before, give faculty quite a bit of leeway to do their own work. Many of the faculty serve as consultants, and some of them actually start company also. So at the time, with the money we got from our special license, we used that as the seed money, and we decided to start our first company, and we called the company Dynamic Instrument Company, lacking better name. And later on, it was changed to Dynisco because the original name was has a conflict with another company called Dynamic Instrument Company. Anyway, we rented a place in the back of MIT, the East Campus, the back of the East Campus of MIT, and a space which later on the whole building was bought over by MIT, becomes now E17 or something like that. And we hired a engineer, another MIT graduate, and to be in charge of the day-to-day operation. Well, both of us basically doing design work, design R&D work only, and so we're still teaching, and also we spend a lot of time, including all the weekends, building up the Dynisco. And the company, actually, we did not require any additional funding from other places. Those days must be easy. I mean, the economical condition and the general condition must be relatively suitable for new companies.
So the products that the company that you designed for the company back then,
yes.
That very quickly already have customers who would like to buy those products.
Correct. We did not have too much a problem. Anyway, the company quickly reached break-even point, meaning meaning what we sell balance out what we use.
Yeah, nowadays that's very hard to come by.
which is that's right. So we were lucky. And later on, we also find a very important application, which is to use it for plastic molding, plastic extrusion. Every extrusion machine requires a high temperature sensor, pressure sensor, to sense the melting pressure. So later on, years later, I mean, the company still exists. I look up a couple of days ago on the Google, and I found the company still called Danisco, and still manufactured pressure transducer for plastic extrusion application, and selling worldwide. So that's almost 50 years ago.
Wow.
And it's still operating, still sell the same product.
Oh.
So it's a pretty long product life.
Right. Yeah. That's very hard. Any of these products, the product lives are probably not over 5 years. If there's 4 years, people are already pretty happy about it.
Yeah. So that's how we start up the first company. And at the time, and after a few years, we felt that we cannot neglect MIT teaching much. Everybody had to write papers and to be able to
And that
advance.
was in the 1960s, right? About 50 years from now?
Let's see, that was, yes, about that time. So we decided to sell the company and concentrate on the teaching, research at MIT. So we sort of climbed the academic ladder to be first to be associate professor, and finally full professor with tenure. And that way we go on for another 10 years or so. And somehow, one day we discussed what we will be doing after we reach the then mandatory retirement age, which is 65. All the faculty has to retire. That was the rule by that time. Later on, because of the government has considered as discrimination of age, the retirement age, I don't know what is now, but sort of indefinite. But at the time, the retirement age was 65. I said, what are we going to do after we reach that age? I cannot imagine myself sitting on a chair on the beach or watch television all the time. And so we said, why don't we start another company? So that's how we started the second company.
So the company, the second company was started mainly to make sure that there's an organization that you contribute to after retirement.
Right. Make sure we have something to do when we reach the retirement age. And but the second company was much more difficult. We use the money from selling Danisco as the seeding money to start the second company. We call it Cetra system. the goal of the company is to design sensors, signal energy transduction. That was the name THAA come from, signal and energy. We figured that our original sensor work still important. Also, my work on the servo control, that's the energy part, to control energy part. So we aim to do both signal and energy transduction from one form change to another form. I had some idea of how to measure very low pressure. At Danisco, we measure general purpose pressure or very high pressure, but it's very difficult to measure very low pressure. So I thought about using variable capacitance principle to measure low pressure, and which requires some design ingenuity. So I have some idea, and I use my at the time we already built this house. We used the basement, not garage like many of new startup companies use their garage. We happened to have a nice basement when we designed the house, a very nice area which I equipped with machineries, and I personally built the prototype of a variable capacitance transducer. Okay, so we use that as a starting product, and for the THAA system. We hired at the time, yes, we hired a student of ours, of YT's, Howie Peston, as the general manager. And because we do not have the time to do the actual day-to-day management, and what we really want to do is research, development, come up with new design, and as I said, the company was much harder going to reach a break-even point. After about 2 or 3 years, we used up the initial funding of ourselves, and at the time, the venture capital was not very popular. There's no there's only one venture capital firm called American Research and Development Company, and that company incidentally originally funded Digital Equipment, which is a large company, and made out many times their investment. Anyway, we were able to, through our friends, introduce some private person who want to invest. It's not friends or person we know, but just people from Wall Street are interested in they call it private placement, and we have a person who has sort of a group and put some money into the company. After another couple of years, the money still used up, and we still haven't reached the break-even point. And we do a second round looking for a fund. There was a few people join again. Of course, the stock price is lower. Finally, in about 1975, I decided that either we gave up or I resigned from MIT and concentrate on the company. So I took an early retirement from MIT and spent my full time managing the company. And after 1 year, the company broke even, and from then on, the company grew and grew very quickly. We moved from a 3,000 square feet building into a 10,000 square feet. Then at a point, we said we should build our own building. So my wife Lena and I was scouting around and finding a good site. Finally we found a site in Acton. So we hired a engineering company, Drummond Brennan. Later on, they help us to design a special designed building, 100,000 square feet, 50,000 square feet, and with the possibility extending to 100,000 square feet.
What were the main customers for these sensor products?
Various, and including aircraft, automobile. One of the demonstration of the sensitivity of the transducer at a trade show was to measure a person's height. You put transducer on the floor and then put on one's head. You can measure the height. You're 5'10" or whatever, really accurately. It was very impressive to be able to be so accurate. And one of our biggest customers turned out to be a Japanese company, Sony, or one of the big semiconductor company. It's not Sony, I forget which one. And they use it in their equipment for they call stepper, and for some reason they require to measure the barometric pressure fairly accurately. But anyway, we found quite a number of users, and the company grew and grew and very quickly. They finally, we both aging, and finally I reached 84-year-old. My brother is 80. He's 4 years older. He was 89. We decided this is about it. So in 2001, 2001, we sold the company. I was 84 years old, and he was 88 years old. And
by that time, the two of you were still directly involved in the management of that company.
yes, I was anyway. My brother was sort of part-time. He actually continued with MIT and starts innovation courses. Some of the early innovation courses were started by him. And so that's my end of my second company.